Thanks for everybody coming out here. That's pretty exciting for us after about a year or so that we worked on this to, bring ideas together on how we can really, make those cleanups as smooth as it gets. And it's been ideas, it's been, inspirations from various sides, whether that was from the placer. Some of these processes are also inspired by some hard rock kind of best practices in their gold rooms. And so yeah, we basically built this prototype to prove to ourselves and to basically be able to show it to you guys what we can do in a cleanup circuit that is almost fully mechanized and pretty much all hands off. Yeah. So we have this all in one container. It's almost like a mini processing plant by itself. And I'd like to run you a little bit through the process before we start it up. Jeff and I are going to start it up, and then we'll walk out and you'll see it all working by itself without an operator in here. And then after that, feel free to either climb up here, check out all the pieces up here, or then downstairs. There's going to be some water running. We have some pumps. All this water gets recirculated. So this is a pretty elegant way. We can run this here for hours if we wanted to. We're not running out of water. We have probably a half a ton or so of material up here that we can run through the circuit. So that's also something that's going to give us some time for everybody to see how it works, and there's no rush. Yeah, the idea really was to make cleanups as less backbreaking as possible, as comfortable as possible, and also as efficient as possible. And with that efficiency, I think the key to this efficiency is to be very consistent, to be slow and steady rather than batches on and off. And that matters particularly for a shaking table, for example, which we have down here. You'll see because this entire system from the start to the finish is one consecutive slow and steady process. As the material gets handled through here, you'll also see everything to move and perform very steadily. This bin up here would be the first step of the process. This bin is actually removable. So it sits on here, but it has its own skid, and it has electrical connections that are just basically plug and play. So this bin holds the concentrate, and it can be taken off from here, taken off with a forklift, or there could be a ramp that could be filled up here behind the container so that you can drive up and take that bin off, take it right to the wash plant, fill it up with concentrate right at the wash plant. This bin is not just a bin, but it also has an auger in the bottom. So horizontally in the bottom there's an auger screw that slowly turns and feeds the material into the gold room. It also has, when you come up here, another detail. You'll find a stainless steel screen, basically a well point, that drains all the free water out. So that free water has to be removed before it can efficiently and at a steady rate auger the material out, feed it out. There's also a vibrator here. That vibrator can be activated from downstairs from the main control station to start and stop and kind of shake the material up a little bit so that it falls down and can actually be drawn out. It's about half full of material, and that is some cleanup tailings from various sites. Some of it is a bit black sands in it, some of it is more blonder material. There may be a little bit of gold in it, and there's also some additional gold that we can add into the system just to show how everything works. So that would be the first step of the process, and then through a hole at the end it drops down into the room, into the container. Downstairs just below us here is a Trommel screen that screens the material at 10 mesh or 2 millimeters. Everything coarser than 2 millimeters goes over a jig, and everything finer than 2 millimeters gets pumped up here to, on the right side of Jeff's, is a magnetic separator. That magnetic separator is a low intensity magnetic drum that really lifts out any steel or magnetite. That magnetite then gets just behind the room. There's a drum, and we collect it in that drum. You can put your hand in. It's beautiful black sand with very little or no entrainment. The reason for that is because we have such a relatively high flow rate of not very concentrated, at this point, not very concentrated material flowing along the magnet. So when the magnet lifts out the magnetite, the chance that there's a gold particle in between the magnetite is pretty low, right? Because the concentration is so low at this point. So entraining gold and basically drawing gold out with the magnetite is a low risk, the way we're doing this here. And then the non-magnetics, everything that's been where the magnetite's been removed, then goes into this tank at the very end. And this tank at the very end is a large tank that has a cone at the bottom. And because there's so much water at this point, just so much water from screening and from the magnet itself, it adds a bit of water. It's way too much water for the table to operate efficiently. So the solids, all the sand, all the blonde kind of sands with the magnetite removed, and the gold settles out in this conical tank right into the bottom of it, and the water overflows. In our case, our water overflows and out into a tank from where we pump it back and reuse it as process water. Over time, it gets a little bit dirtier and dirtier as we reuse and reuse and reuse it, but in practice, you would have a much larger pond and a somewhat clean water source so that you wouldn't have to fully recycle what we have to do here. This tank also acts as a really good surge bin, because this process here on my left, which is the feeding and the coarse gold recovery, can run at a different feed rate than the process on the right, as long as this bin is there and it has the capacity to store material. So if we feed this system here at, for example, 1 ton per hour, but the table can only take half a ton per hour, that's no problem, because all that means is that bin is filling up slowly, and once we're done here, we just need some extra time for the table to catch up. Yeah? Or it could even be that this process on the left, the feeding, the screening, and the jigging, is done first, while it all gets stored in the conical tank, and then afterwards the conical tank and the table is run. So there's various options. It's very, very flexible, and typically, though, everything would run at once, yeah, without too much attention to whether the feed rate here is exactly what the table needs. It doesn't really matter, because there is this tank in between that buffers it out. Yeah, and then from the bottom of the tank, there's a hose pump, a peristaltic pump. It almost works like pushing out material out of a toothpaste. So it pushes material with basically an arm or so. It pushes it through a hose, it massages that hose so that it feeds onto the table at a very steady rate. And we can then see the table operating, and the table produces mainly 3 products. That's really the tailings of the table. Our tailings get pumped out. That's final tailings. But then there's a major section of the table, that's the middlings. And those middlings get basically just recirculated back up here. They just go around and around and around until the middlings decide to either go into the tailing stream, or we catch them with our gold stream. Yeah? This middling stream is a thing. This middlings recirculation is something that every kind of hard rock processing plant is very familiar with, because that's kind of how all these processes are set up, with a lot of recirculation to really no chance for losing anything, because we don't fear it going into the tailings. It's really this large middlings band that may have gold going with it, but this gold is coming around and around and around, and ultimately it's going to find its way into our concentrate. So you'll see this concept going. It's very convenient to operate too, because there's really no need to precisely cut the gold, because we know we got all this confidence that it comes around again and it's not lost. Yeah, and then right below us here is really the section between the process on the coarse side, screening and jigging, and the fine side, the tabling. That's where we have a, you know, an electrical panel where we can start-stop equipment, and we have a water manifold where we can adjust the water flow rates. And it's really this station right below me here is where an operator would typically be and monitor the process. But you'll see when we start it up, we can walk out here and there's no need for anybody in here. It will just do its thing by itself. We're pretty excited to start it up and show you. All right, first stop here at the gold room is the auger bin feeder. The auger bin feeder receives concentrate from the wash plants or from centrifugal concentrators, and it can hold approximately 1 ton of concentrate. This entire bin feeder here is on skids and can be taken off. This is its parking position, but it can be taken off, filled, and brought back to the plant here, to the gold room. And or it can be filled in place, of course. We see here there's electrical quick connects, so the machine can easily be uncoupled and coupled back on. What we see here is the drive. The material that's in the auger bin gets drawn out with a screw, an auger screw, that's driven by this electric motor and gearbox. And we can have a look here. We'll see the actual material filled up. There's approximately one ton or half a ton or so of concentrate in it right now. So what we see here is feed material. That would be typical concentrate, raw concentrate, as the auger bin brings it out of the bin and then drops it through this chute, and then drops the concentrate down through the chute. From the chute here, it gets washed into the Trommel screen. So what we see here is a Trommel screen that screens at 2 millimeters. Everything coarser than 2 millimeters will fall through the screen and then gets pumped up to the magnetic separator. And everything coarser than 2 millimeters would be fed onto this jig here. On this jig, we can feel that our hand gets basically drawn into the jig. And the jig is equipped with steel ragging for the collection of relatively coarse gold nuggets. So anything coarser than 2 millimeters will be collected here in the jig. That's the jig mechanism. So it's a mechanical operated jig, a duplex jig that jigs one section of the bed and then the other section of the bed, and does that in an alternating motion. Anything coarser than 2 millimeters, as I said, over the jig and then out into the tailings. The gold is captured in the jig bed and then removed at the end of the process. And the fines that drop through the Trommel screen get pumped up to the magnetic separator. Okay, here we're at the magnetic separating station and the so-called decanting tank. The magnetic separator receives the feed from basically from the screen, and that's all fine sand material, less than 2 millimeters in a water slurry that gets pumped up here and then flows through this wet drum magnetic separator. It's a low intensity magnetic separator that primarily is there to remove black sands, to remove magnetite. And the material flows through this bath with the drum turning inside of the bath, and then the non-magnetic fractions, both of these streams that we see here are the non-magnetic fraction, basically looking like sand like this. That's screen material, blonde, relatively blonde sand that we have coming out there. That's going into this tank. This tank here is the tank that then it settles out and it feeds the table. Okay, so now we're at the shaking table. Feed to the shaking table is drawn from this conical decanting tank. The bottom of the tank has a gate valve and then feeds the slurry, feeds the fine less than 10 mesh or less than 2 millimeter material into the hose pump. The hose pump then meters at a very consistent rate the feed right onto the table. A table feed box here distributes the feed onto the feed corner, and from here we can very much see the material spread out on the table. The much lighter material would run down here. We can see that the color is a lot lighter, and we can see the denser material with a much darker color here. We can also see some gold specks coming by here. Probably a little hard to see in the video. That's material that would collect right in here. And then at the end of a cycle, screen that into multiple 4, 5 narrowly sized size fractions, and then retable it to get it fully clean to a sellable product.